Okay, so we are continuing on with what we looked at yesterday, where we're taking a situation, we're creating an input-output table, we're writing a rule, which is the equation, but we're also going to add two things to it today. The first thing that we're going to add is we're going to decide, is this an additive relationship or a multiplicative relationship? And then we're going to create a verbal description that will compare the relationship between the output and the input. So let's start with example one. Example one says, for a certain brand of dog medication, the amount of medication that a dog needs, M. Now remember, that's important. It tells me what each variable is. So the medication is M, depends on the weight of the dog, which is D. So when we look at our input-output machine, the weight of the dog is the input, the amount of medication is the output. Our table is even set up where weight of dog in pounds is D. We have our input, amount of medication in grams is our output. But then we have this giant part in the middle, our process column, which is where we're going to write how we're going from each input to each output. So when I look at my input of 3, my output of, my input of 6, my output of 3, there are two things that I think of in my brain. I think of I can do 6 minus 3, and that will give me 3. Or I can do 6 divided by 2, and that will give me 3. So both of those processes work, but I have to figure out which one works for the entire table. So if I were to do 8 minus 3, that's going to give me 5, but my table says 4. So my minus 3, it's not the correct process. So what I'm doing here is I'm doing 6 divided by 2. That gets me to 3. 8 divided by 2 will get me to 4. So I know this whole divided by 2 is going to work, but there's another way to write this. Yes, I can continue doing 8 divided by 2. I could do 10 divided by 2 will give me 5. But another way that you might see it written is instead of writing divided by 2, it might be written as times 1/2. Because remember, dividing by 2 is the opposite of multiplying by 1/2. It gets me the same thing. When we sing our song that goes, dividing fractions is easy as pie, just flip the second and multiply. So if I were to flip the second, that divided by 2, it becomes 1/2 and I'm multiplying. So they're the same thing here. So I'm going to write 12 times 1/2 will give me to 6. And then this is just saying whatever I'm doing to D, so I could do D divided by 2 or D times 1/2, that will get me to M. So I need to write a rule, and I'm actually going to have two rules here depending on which process I pick. So I'm going to do the first one, divided by 2. So if I were to write my rule, my output, which is M, is equal to D divided by 2, but I'm going to write it a little bit differently because I don't want to use the division symbol. So remember, another way that we can write division is as a fraction. So D would be my numerator, 2 would be my denominator. So this is still D divided by 2. Or I can write it using the multiplication. So that would be M is equal to, now if I'm multiplying, I want to make sure that that number that I'm multiplying by, remember we call that a coefficient, goes in front of the variable. So 1/2 D. So both of these are correct ways to write our process, to write our equation, our rule of what's happening here. But then we have to decide, is it additive or multiplicative? So our order of operation song that goes, it's fun to do the G-E-M-A. Remember, when we talk about M, when I ask you what are the two things that are multiplicative, that's multiplication and division. Our two things that are additive are addition and subtraction. So I just need to decide what operation is happening inside of my rule. So I have division here, multiplication here. So this is a multiplicative rule. Okay, now I need to describe verbally what is happening. So it says the value of M is blank compared to the value of D. So it wouldn't make sense to say the value of M is divided by 2, the value of D. It wouldn't make sense to say the value of M is times 1/2 the value of D. Our value of M is just simply 1/2 the value of D. So 3 is 1/2 the value of 6. 4 is 1/2 the value of 8. If you're ever unsure about your verbal description, try plugging some of your values in. See if the sentence makes sense. All right, looking at example 2. Example 2 says a student decided to add $1 to her piggy bank each week. The total amount of money she has, so the total is T, depends on the number of weeks, W, she has been adding money. So my input-output machine, the number of weeks is the input, the amount in the bank is the output. So we've got our table set up. So I need to figure out what I'm doing to go from the input, W, to the output, T. So I have an input of 1, an output of 11. So the two things that I think of are I can do 1 plus 10 will get me 11, or I can do 1 times 11, which will give me 11. So to figure out which rule makes sense for the entire table. So 2 plus 10 would give me 12, but 2 times 11 will not give me 12. So it looks like my rule here is plus 10. So 1 plus 10 gets me to 11. 2 plus 10 gets me to 12. 3 plus 10 gets me to 13. 4 plus 10 gets me to 14. So W plus 10 will get me to T. So if I write my rule, my output T is equal to W plus 10. So is this an additive relationship or a multiplicative relationship? The operation that's happening here is addition. Addition falls underneath the additive, so this is additive. And then for my verbal description, the value of T is blank the value of W. Since I'm adding 10 to my W, the value of T is 10 more than the value of W. So again, I could plug it in and say 11 is 10 more than 1. 12 is 10 more than 2. Okay, on the back. Says a car is traveling at a speed of 65 miles per hour. The distance traveled, which is D, depends on the amount of time, T, that the car has been driving. So time is my input, distance is my output. So to go from 1 to 65, I have two options. First option is doing 1 times 65 will give me 65, or 1 plus 64 will give me 65. So if I do 2 times 65, that would give me 130, but 2 plus 64 does not give me 130. So my rule is times 65. So 2 times 65. Now I've got some where I have to fill in the missing value. So 3 times 65. So I'm going to come over here to the side where I got some room to work. So 5 times 3 is 15. Write the 5, carry the 1. 6 times 3 is 18, plus 1 more is 19. So 195. Then I would have 4 times 65. So 5 times 4 is 20. Write the 0, carry the 2. 6 times 4 is 24, plus 6 more is 26. So 260. And then I'm taking T and I'm multiplying it times 65. So my rule here is my output, which is D, is equal to T times 65. But remember, I want to put the coefficient, what I'm multiplying by, in the front. So 65T. Now it says additive or multiplicative. My operation here is multiplying, so this is a multiplicative relationship. And then my verbal description, the value of T is 65 times the value of W. So 65 is 65 times 1. 130 is 65 times 2. So we've got our additive relationships, our multiplicative relationships, but what happens when I get to a table like this? It says, today we're going to compare how many letters are in someone's first name to the number of siblings that they have. So it says the number of letters in the first name, that's the input. The number of siblings, that's the output. So Emily, 5 letters in the first name, has 2 siblings. So my process here could be 5 minus 3 will give me 2. Hannah has 6 siblings in her name. And to go from 6 to 2, actually, let's go back here to Emily for a second. Emily would be 5 minus 3 would get to 2. Hannah, to go from 6 to 2, I could do 6 minus 4. Or I could do 6 divided by 3. Madison has 7 letters in her first name and has 0 siblings. So that would have to be 7 minus 7. And then Charlotte has 9 letters in her first name and has 4 siblings. So that would be 9 minus 5. So when I look at all of this, I can't use the same process over and over and over. So this one, there is no rule. It's not additive or multiplicative. And I can't write a verbal description. There is none, because this data right here has no pattern. It has no relationship. It has nothing. It's just a bunch of random X values and Y values that don't have a rule, that don't have a pattern. So there are some times that our tables here, that our patterns don't have a rule. They don't have a reason why they go together. This is just simply showing data. That's it. That's all that's there. There's no pattern there. It's all totally random.